Hi everyone, this is going to be a video walkthrough on question 2 on CS621B exam prep discussion 3 in spring 2021. Exciting, let's dive in. So for this question, we will be implementing the method EvenOdd by destructively changing the ordering of a given int list so that even index links now precede odd index links. Okay, so how that's going to look is if we are given the int list containing elements in the order 0, 3, 1, 4, 2, 5, we first notice that the indices go 0, 1, 2, 3, 4, 5. So we can see here that the even indices 0, 1, 2 now precede all of the odd indices 3, 4, 5, right? So that's basically the logic here. And what's important to understand is that this function is also destructive. So what does a destructive linked list function entail? It means that instead of creating new linked list objects, we reassign the dot rest pointers, right? So how that's going to look in terms of a quick example is that if we're given the linked list 0, 2, 1, 3, our end result should be reassigning the pointers. Let's put a solution here, such that it goes 0, 1, and then since 1 is the last even indexed element, then we go back to the first odd index element, which is, okay, so then we go back here, and then we go here. So that's how our solution should look like, right? So the question really comes down to if we are given a linked list that looks like this, how can we change the pointers such that we add in these new blue pointers in lieu of the dot rests that we had before, right? That's all we have to really figure out. So let's try to figure out like how we can approach this problem, and let's try to build some intuition, okay? So let's go back up to the top. I'm going to build some logic. So there's a few things that I think first strike me. And the first idea is that, let's use black. Let's connect each odd link to the next odd link. And in the same manner, let's connect each even link to the next even link. Okay, so that's my first line of reasoning, is that each odd link should be connected to the next odd link, and we should connect each even link to the next even link, right? And what that looks like is the idea that we have an odd link, and an odd link refers to a link of an odd index. Okay, so in this case, the odd link would actually be this one, and we want to connect to the next odd link, which in this case is here. Okay, so that's the first logic. So in order to like achieve this, one idea that I have is that what if we create two pointers, okay? What if we create an evens pointer and an odds pointer, right? And evens will be pointing to all of the even elements, so it'll start pointing here. Odds will be pointing to all of the odd index elements pointing here. And then each time what we do in this iterative manner is we say evens, you point to forward. Odds, you point to forward. And then what we will do is we will say odds, let's move over here, right? Let's move to your new dot rest. In the same manner, let's tell evens, hey, let's move you to your new dot rest, okay? And in this slide, we can keep repeating this pattern until we get to the end, okay? So that's like the general logic for the first part. The next part is we need to figure out, once we get to, I'm going to erase this just for the sake of space. Actually, no, we can move it down. Okay, finishing the thought from above, once we get to the end, how do we connect the last even link to the first odd link? Okay, so what that is saying is that when we are at the last even link, which in this case is this one right here, how can we connect that to the first odd link, right? What we're trying to do is connect this guy, give me a sec, here, right? So in order to achieve that, my idea is let's have a original pointer, let's call it second, that will point to the second element in our linked list. In other words, it'll point to the first odd index link, so that when we have evens and odds, as they keep moving down this linked list, eventually evens will get to the last even index link, and then we will set evens.rest to be second. Okay? So the last thing that we really need to figure out is how do we know that we're at the end, right? What's that stopping condition, like when we actually want to exit this iteration pattern? Okay, so let's try to figure that out. And I'll pose that question just right here so we have it written down, is how do we know we are at the end? Right? It's a very tough question because it seems that we can just keep assigning the dot rest, but it looks like it may get a little tricky to figure out when we should actually terminate this process, right? So I think the best way of answering these type of questions is walking through a couple examples. And that's what we're going to do right now. Okay. So looking at this example, let's assume that we're at the next iteration. Okay, we already did the first iteration where we added in the green pointers. Now that we're here. Okay, so what we'll notice is that we actually want to end right now. The reason we want to end right now, the simplest way of thinking about it is that we want evens to be at the last even index link. And now evens is at the last even index link, which means we should terminate the process of looking forward, right? Okay, so how we want to do that is we want to say that odds dot rest is null, which implies that we are at the end. Do you guys see that? Because we know that in this case, since the linked list is of even length, when we're at the last even index link, it implies that odds.rest is null, right? Cool. Okay. So we dealt with the case of what happens if we're given a linked list of even length, but we still need to deal with the case of what happens if we're given a linked list of odd length. So let's dive into one of those examples right now. Okay, so now we see that we have a linked list of an odd length. So does our logic still apply from before? Let's try to replicate it quickly. So what we're going to do in the same manner from above is we'll have an evens and we'll have an odds. Okay, and then each iteration, what we'll do is we will set evens.rest to equal evens.rest.rest, and we will set odds.rest to equal odds.rest.rest, right? So how that looks is, let's use another color. We will set evens.rest to be equal to evens.rest.rest, and we will set odds.rest to equal odds.rest.rest. And then what we will do is we will say evens, you will now be evens.rest, which is right here. And we will say odds, you will now be odds.rest, which is here. Okay. And now what we can see here is that evens isn't at the last even index link, which means there's still a bit more work that we have to do, right? More precisely, what I want to do is I want to run one more iteration of this pattern. Okay. So what we're going to do is we're going to say odds equal odds.rest. So now what's going to happen is that or odds.rest is equal to odds.rest.rest. And what that does, it sets this to null, and now odds is null, okay? And then we will set evens.rest to equal evens.rest.rest, which sets it like so. And then we will move evens here. At this point, it's pretty obvious that we want to terminate. We want to exit this iteration. How do we know that we're at the end? Well, there's two ways. The first way is that odds is null. The second way is that evens.rest is null, right? And these are equivalent checks. So let's translate this logic into code, okay? The first thing that we want to do is we want to create 3 pointers: evens, odds, and second, right? Remember that second is going to be pointing to the second linked list in our chain, so that once we get to the last even index link, we can point the last even index link all the way back to second, right? The only problem that you guys might see is that we can only really keep track of 2 of these pointers. So what we're going to notice is that we already have a pointer list, LST, right? So can we replace one of these pointers that we've created with LST? And what we can see here is that we can perform the exact same logic, but just replace evens with LST, right? So what we're going to do is we're going to create odds and second in this first line right here. And let's forget about the base case for now. I honestly like going through the logic of my code and then going back to see what necessary base case I need. So what we will say here is we will say that int list second okay. So what we're going to say, sorry, I cut out for a quick sec, is that int list second is going to be equal to list.rest. In the same light, we will create an odds pointer, which will also start off at list.rest. And then what we're going to do is we're going to keep iterating while we aren't at the end. And we know that we're at the end because odds.rest is null or evens.rest is null, right? That means we're at the end. So we're going to keep going while these both aren't the case. And we have to first check this criteria because evens.rest comes before odds.rest, right? Evens is always before odds in the iteration pattern. Okay, so while evens.rest is not equal to null and odds.rest is not equal to null, what we will do is we will say, I'm sorry, I used evens, but I said we will switch that with LST. List.rest is equal to list.rest.rest, right? And this is the logic we've kind of iterated a few times over now. And then what we will do is we will move list and odds to list.rest and odds.rest respectively, right? And then after this logic right here, once we exit from the while loop, the last thing that we need to do is take that last even index link. Actually, yeah, in this case, it would be this one over here. It's my bad. And we will point that to second. So we will say evens, or in this case, list dot rest is going to be equal to second. So that is the solution for problem 2. I hope you guys enjoyed it, and I encourage you guys to try diving into the last one as well. It's a good practice.